All right, so we're going to start looking at parts of the Earth. So we have two different models that we can use to look at the parts of the Earth. One of them is going to be described as the compositional, and the other one is discussed as the structural model. Right, so when we are looking at these different layers, you're going to kind of have to have an idea of what's going on. So when we're talking about the compositional model, you're going to see that you're going to have the crust, mantle, and core, and that's really looking at what they're made of. Or if you have the structural model, you're going to have the lithosphere, asthenosphere, mesosphere, outer core, and inner core, which is really going to start looking at kind of what they act like and how they behaved. So the crust has two different parts. One that's in the continent, it's with land, and one that's in the oceanic, right? And these are going to be pretty much solid parts and mainly made of certain elements for the most part. And then you have the mantle, which is upward transition and lower. And then you're going to have the core, which is going to have two different parts. Well, it's just the core in this situation, but it's outer is liquid and the inner is solid. And it's made of pretty much iron. And these layers are subdivided because of how seismic waves go through them, the speed that they move. So the crust is pretty much, as we said, this is a compositional model. It's mainly composed of silicon, aluminum, iron, and calcium, right? And there's some other elements that are in there. But so the most part, right, we're gonna have these pop up there, and that's why we're gonna have so many silicate type minerals that we see pop up. That's what it's normally made of. So when you're looking at the structural model, you're going to see that the crust and the upper mantle are kind of combined into what's called the lithosphere, which is I believe means like earth or hard in Greek or something like that. And it's going to be solid. Then you have the asthenosphere, which is kind of this like goopy part of the mantle that's like not solid, not it's like more like a liquid. It's going to behave, right? And it's going to be kind of where a lot of movement happens. And then underneath that, you're going to have the mesosphere, which is kind of solid again, then outer core, which is kind of liquid, and then inner core, which is solid again. So this is what we're talking about is structural. The chemistry of the mantle is that you're mainly made up of magnesium and iron, right? The two main elements that make up the mantle. So as we say, when we're talking about compositional, this is what makes them up. This is why we use it, because chemically speaking, this is what they're made of. And then you're going to have a whole bunch of these magnesium silicate type rocks that are formed in that area. So the basic chemistry of the core, right? When we're talking about the core, we're not talking about whether what its structure is, but we're basically saying that it's made up of iron and nickel. And these are mixed together. They're heat and pressure, and then because of this heat and pressure, you're going to have some parts of it that are liquid, some parts that are solid. Solid, there's enough pressure to keep it solid. Liquid, it's just too hot. Even though there's a lot of pressure, it's keeping it liquid. So what you see is that they're mixed under great heat and pressure. When they cool, there's going to be this greater strength in the singular metal. So this is, when we say like an alloy, they've mixed together to be a lot stronger, and they are not chemically combined, right? But they do mix together to have different sort of properties in terms of strength, right? So this is Earth's core's magnetic field, and the magnetic field is formed because of the solid matter iron in the core of the Earth is kind of creating this magnetic field as it moves around. Anytime you have metals moving, you're going to create some sort of magnetism. Iron is a good conductor of electricity, if you wanted to know anything that most metals are. And they have the sea of electrons that just allows them to move electrons. And when you have electrons that are moving, you create electricity. More fun facts is that Earth's magnetic pole is different from its geographic pole. So that means that where the magnet points is not necessarily where the top of the Earth is. And it's where the magnetic lines of attraction enter the Earth, whereas geographic North Pole is where the Earth spins on its axis of rotation. So that's different. That's where it spins around. And every 4 or 5 million years, and I think we're due for one, magnetic north flips. So then it turns to south. And this way we can know this through looking at rocks and their magnetism and how we see iron pointing in them. It's kind of fun. And we learned this by studying the ocean floor. And it's imprinted in the rock. So they point in one way, then they point another. That's how we know it shifts every 4 to 5 years. All right.